right, so welcome back. Hopefully, you kind of figured out how we're going to use this Zoom and screen sharing and the YouTube video system to get through the lessons together. Again, at any time, you can pause these videos, you can go back. So, as I ask questions or ask you to do something, and I'll try to remember to tell you to pause the video and do it. Okay, you have access to the slide presentation that I'm using in the video as well. All right, so today's objectives moving forward, as I always do in class and show you, is we're going to look at how to write these chemical equations. So in the past, we talked about how you have this reactant, and then you're going to have the arrow showing you where you're going to have what you're producing or the product. Okay. So there's a little more involved than just writing that of what's the ingredients and what we're being produced. We're going to demonstrate how to do something called balance the chemical equations. I alluded to this earlier where if you put 10 chocolate chips into your recipe, your cookies are going to have a total of 10 chocolate chips spread throughout. And that's what we have to look at here. What you put in is what you get out. It may be rearranged in a different form, but it's still going to be there in some form. And that's this law of conservation. Remember, I've told you over and over, we've had lots of conservation laws. All that tells you is what you start with is going to have to equal what you end with or finish with. So the total stays the same. And so that's what we're going to look at with these chemical equations. So those are our objectives. All right. So looking at this equation, this is taking carbon combining with oxygen, O2, and yielding or producing carbon dioxide, something you've all heard about. Now, the question is, will this recipe work? And when I ask about that, again, we go back to food. If you don't have enough sugar, your cookies aren't going to turn out right. If you don't have chocolate chips, you can't have chocolate chip cookies. So if you look here, what you start with is what you end with. And I gave you that diagram in the last presentation. Um, Here, sorry, let me get you my writing tool. I have one carbon atom. Okay. So when we look at the reactant side, I have carbon and I have oxygen. I have one carbon atom that's told me by this number here, there's nothing there. So it's understood that it's one. I have two here. So that tells me I have two oxygen. On the product side, again, I have carbon, I have oxygen. Oops. Yeah, let me get rid of that there. Remember, it only goes to the one that it's attached to. So I still have one carbon and I have two oxygens. So looking at it, if you compare the left to the right side, you have one carbon going in, one carbon coming out, two oxygens going in, and two oxygens coming out. So yes, this one will work. And that's the idea that we're talking about of balancing these equations. Now they will not always be this easy or this straightforward, and I'll walk you through these processes, and you're gonna have a little lab sim to get used to doing this and practice doing this. But what you start with on the reactant side, the type and the amount has to equal the type of atoms and the amounts that you see come out. And so what is a real easy way to compare it here. All right. So, just as a review, a chemical equation is a symbolic representation of a chemical reaction. It is the shorthand way of showing how atoms are rearranged. Remember, that's the whole idea of a chemical reaction. Atoms are rearranged, bonds are broken and form new ones, and they rearrange. Again, you keep equating it. I keep coming back to this analogy of it's a recipe. You have certain ingredients and you have certain products. So again, your arrow is always pointing to the product side. So in this case, the left side would be my reactants, would be carbon and oxygen. My product would be carbon dioxide. Again, don't memorize left and right. Look at the arrow. The arrow is always going to point to the product side. So just like in math class or when we add or combine things, we're going to use that plus symbol. Okay. So when you looked at that example of carbon plus oxygen, that's telling you you have more than one ingredients. Okay. So we could have multiple ones. We could have multiple plus signs. You aren't limited by just one. So it just means you're combining different types of atoms or molecules when you see that plus sign. You're combining them, in other words. And here's a kind of a graphic representation of what we just did. You got one carbon, one carbon. Okay, oxygen over here, I have two. Over here, I have one, two. So I have a total of two as well. New bonds are just rearranged. Same atoms, same number. Okay. All right. Now, in math class, if I give you this and I asked you what this for was, hopefully you could tell me is that's what we talk about as being a coefficient. When we talk about that in equations, you're going to see that we also have coefficients, and they're going to be the numbers out front. Remember when we had O2, we called these subscripts. Okay. The subscript only gets attached to what it's or gets applied to what it's attached to. So when I wrote it as carbon dioxide, I had CO2. The two only applied to the oxygen. It did not transfer to anything else, only what it's attached to. The coefficient, however, you want to think about math class. If you have something like this, okay, 3 times x plus 2, hopefully you know you're going to distribute that coefficient throughout, and it's going to apply to everything it's attached to. So 3x plus 6. The same thing goes true here. So if you have 2 as a coefficient of CO2, what that tells you is you're going to have 2 molecules of CO2. So in essence, you're actually going to have apply that 2 to both of these. So you'd have 2 carbons and 4 oxygens. Just distribute it just like you would in math class. Okay? So a coefficient is different than a subscript in that a coefficient gets multiplied by everything it's attached to. Your subscript only gets applied or multiplied by what it's attached to, just that single entity, that single atom. Okay? So there's a big difference there. So for instance, if you had 4H2O, you're having 4 molecules of water. Well, to do that, you are quadrupling the recipe. It's like doubling your recipe. If you double chocolate chip cookie recipe, you have to double everything. You can't just double the egg or double the sugar. You have to double everything. So that 4, because it's a coefficient, gets applied to everything it's attached to. So in that recipe, you would need 4 hydrogens. Whoops, 8. Do a little math here. 8 hydrogens, and you would need 4 oxygens to create that. Okay. All right. So here's the steps of how we're going to what we call balance a chemical equation. Okay. So these are your steps. I would be pausing the video and making sure you get these down. These is what we're going to talk about when you balance a chemical equation. These are the steps. Okay, I'm going to take you through the baby steps. Hopefully, as some of you get good at this, you don't even need it. But this is just the best way that I have found over the years to help you guys kind of figure this out. And we'll walk through each one of these. Chart the reactant and product. Okay, so we're actually going to create a kind of a chart to compare everything. In that chart, you're going to list the individual atoms, so the type of atoms that you find. Okay, using the subscripts. Okay, you're going to list how many. So you're also going to figure out the amount of each kind. What you need to do then, step 4, is to check if both the reactant and product have the same type and the same amount. That is the key. These two things are what we're trying to get. Okay. If yes, just rewrite the equation. If no, I'm going to show you how to balance it with and tweak it with coefficients. Okay. So again, I would pause the video and make sure you get these steps down. So let's walk through an example here. Here I have nitrogen and hydrogen combining, okay, to make an ammonia. Now, first step, create my chart. I'm going to have a reactant side, and I'm going to have a product side. Okay. I'm going to list the type, so nitrogen, hydrogen, and I'm going to break everything apart. Just single atoms, nitrogen and hydrogen on the product side. Well, that's a good start. I have nitrogen, nitrogen, hydrogen, hydrogen. And if you have lots of things, I like to match them up if I can, if they're on the product and the reactant side. Now, step two said list how, or step three said list how many you have of each one. So I have two nitrogen, I had two hydrogen. On this side, my subscript is one. Hydrogen, I had three. Okay. So that's an issue. The types match, but the amounts do not. So this recipe would not make good chocolate chip cookies. All right. So now you have to look at where you're missing. Okay. Now, obviously, hopefully you can recognize that they're both missing some. And so you can pick or choose whatever one you want to start with. I'm going to go ahead and just go down in order. I have two nitrogen on the reactant side, one on the product side. So that tells me I need more over here. Now, I like to put what coefficients I'm going to do up here because you don't always get it right. It's kind of a trial and error. So, what could I multiply 1 by to get it to 2? Because that's what I need. I need to multiply this 1 by what number to get to 2? A 2. So, I'm going to put a 2 up here as a coefficient, a possible coefficient. Okay. Now, because it's a coefficient, it gets applied to everything. So, 2 times 1 is 2. Okay. 2 times 3 is 6. Well, that fixed the nitrogen part. See how I have two now here and two here? So that's okay. But what about hydrogen? I'm missing hydrogen on the reactant side. Okay. So I'm going to go find hydrogen. It's right here. I have two. Over here, I have six. All right. So I need to multiply this by something. Can I get it to six? What could you multiply two by to get to six? Three. So if you'd multiply by 3, that's the only thing it's attached to, so I don't have to do anything else. 2 times 3 is 6. And so now the type match on both sides and the amount match on both sides. And my last step then is just to drop down my coefficients. Any coefficient I used, I didn't use anything here. Drop down my coefficient, drop down my coefficient, and rewrite it. So my answer would be N2 plus 3H2 produces N, whoops, 2NH3. Okay. The only thing when you rewrite it that you're ever going to change are the coefficients. You don't ever change these ratios, even though you're tinkering with them down here. This is your answer, your what we call your balanced equation. That is the cookie recipe that would work. Okay. So again, let me back up. I set up a chart, reactant product. I put down what I had on the product side, the type or the reactant side. So this is the type of atoms I have. This is the type. And then I just listed the amount, 2 and 2. Nitrogen, I had 1 and 3. And then I set about using some coefficients to balance it out. Okay, so let's try this one. If you feel like you're getting this, I would really recommend you pause the video now. Try to do this one on your own before you watch me work it out. All right, so on the reactant side, I have copper, Cu, and I have oxygen. On the product side, I have copper and I have oxygen. So that's a good start. Okay. Now I'm going to look at the subscripts. I have one copper, two oxygens. I have one copper and one oxygen. Coppers match up, and that's good. Oxygens do not. All right. So where am I missing oxygen? I'm missing it over here on the product side. What could I multiply 1 by to get over to this 2? 2. The problem is it's attached to copper. So I have to multiply it by both. So 2 times 1 is 2. 2 times 1 is 2. Well, I fixed oxygen, but lo and behold, I screwed up copper. So I have to go back to copper. Where am I missing it? Over here on the reactant side. What could I multiply copper by? 2. 2 times 1 would be 2. Now, why doesn't it go over to the oxygen? Because you're separated by this plus sign that cancels out your coefficients. So if you look here, the copper's okay, the oxygen's okay. Now it's time to just drop down any coefficient I used and rewrite it. So 2Cu plus O2 is going to produce 2 copper oxide. Okay? And that would be your answer right here. That would be your balanced equation. Okay? Now, why are we doing this? The sciencey way of saying it is matter cannot be created nor destroyed. It's a conservation law. Whatever you start with has to equal what you end with. Okay. So again, just think of a recipe. If you're going to make chocolate chip cookies, you got to put chocolate chips in there if you want them out. If you put 50 chocolate chips into your mixing bowl, all your cookies are going to end up with a total of 50 chocolate chips. They're spread apart in all the cookies, but they're still there. That's all we're doing with this. So when we balance these equations, that's all we're doing. We're showing that the mass is conserved, that the type and the amount we start with is going to equal what the type and the amount we end with. Okay? That's all we're doing. So again, just as a summary, a chemical react or a chemical equation is a symbolic representation of a chemical reaction. It shows how atoms are rearranged in the reaction. It's the recipe. It's the instructions. It's how much you have to put in. It's the types you have to put in. Equations must balance. What you start with is what you end with. And that's what we did with the chart and with the coefficients. There must be the same type. Okay. So two things here have to have the same type of atoms on the reactant and product, and you have to have the same amount. If not, we have to use those coefficients used to balance it. So the type and the amount have to be the same on both sides. And if you set up that chart like I showed you, that makes it an easy way to kind of see that and get around all the mess. The chemical equations must be balanced because matter cannot be created or destroyed. Just going back to that old kind of weird example I keep going back to with the chocolate chip cookies. And, if you double the recipe, you have to double everything. If you have 10 chocolate chips in the recipe, all your cookies are going to end up divvying up those 10 chocolate chips. You're not going to magically have 50 chocolate chips in your cookies if you only put 10 in. Uh, what you're going to be doing on one of your assignments is, and I'm going to be giving you is a doc here, and it's going to take you to one of your sims. Okay, it's the Phet Sim, and it's going to ask you to do the same thing. It's going to ask you to do, and I'll bring that sim up here in a second here, but it's going to have you walk through this and try to figure out. I would highly recommend that you use the chart, okay, method on a paper if you want to, or on this doc if you so choose, but use that and the sim in conjunction so that you get good practice on how to balance these equations. If you look at the sim, okay, you have a variety of tools, okay. This one's nice. It kind of shows you the balance of nitrogen and hydrogen because those are the two atoms. So let's just say I add one here. You can obviously see that I have two on the left side, but I have zero over here. So it's not balanced, literally. Again, when you use this sim, I would make sure that I'm doing it with the chart and using this as a tool. Now, one caveat, um, when we do this, or you see this in textbook, this is kind of a bug in this. You, when you don't see a coefficient, just like in math, you assume it's a one. Here you have to, and so I would go through when you do these sims is start all these at one and then go from there. Okay, so that's just kind of a little bug on that thing. Here's how you get to the three different forms, or the three different chemical equations that you're going to do from that chart, from that doc. The other tool you could use is a balance. Okay, it uses a bar chart and it kind of goes up. So whichever works for you. The last part is going to be the game. So it's going to give you a variety of games, just like you usually do. Level one, two, three. You try them as many times as you need to. Again, do a screenshot so I know that you completed them and what your score was. Again, that'll be on a doc. That'll be a separate assignment to see how you do with this. Again, you have the video. Rewind it, pause it, use it. You have the raw Google slide presentation that I used for this, and then you'll be doing this lab sim to practice balancing these chemical equations. Okay. Again, if you have any questions whatsoever, just make sure you email me, contact me, get a hold of me. Make sure you're doing this. Okay. And again, make sure you stay on top of things, watch your due dates, and again, email me if any questions come up.